The idea came from the Chinese philosopher Confucius. One picture is worth 1,000 words. Well then, what is the value of 1,000 pictures, 10,000, of things never before seen or experienced? The cameras of space provide the images, and the images themselves help provide the answers. By the time this film is over, you will have seen more than 20,000 separate images from these and other cameras, of things either never seen or experienced. The Earth, the Moon, the Sun, and the stars. The images of the space program. This new view of space are but mere extensions of man. They show him things he cannot see or easily perceive. They magnify or make smaller. They freeze time and event for later study. And they compress time for the same purpose. They help us to find the peculiar reality that is space. This film is a record, a partial record, of those images. Images of airplanes on the very edge of space and rockets exceeding the limits of Earth. Images of a satellite unfolding itself to perform in orbit. We've studied the habits of liquids in zero gravity and in the same condition the habits of man. We've watched men go about their professional duties, American men, Russian men. And we've watched them in more personal moments. The images show us materials under brutal heat and pressure, and the designs for new vehicles. Through these pictures, we've watched a wheel on the moon and on a wet runway. They've taught man how to land on another planet and at a small-town airport. The images show us the airplanes of tomorrow and the violent waves left behind, the vortex of air and the vortex of fuel at zero gravity. We've seen man on the moon and the rocks he's collected from the outside and the inside. And questions: how do crystals grow? What is light, energy? How do cells grow? What is life? Throughout, we've seen the faces of men under stress. The faces of yesterday's missions, today's flights, and tomorrow's journeys. Small events, big occasions, the cameras were there. Big occasion, the launch of a Saturn rocket. The press, the curious, the sightseers have not yet arrived with their cameras and lenses and film. But the engineers and technicians have, with theirs. Nearly 200 cameras and thousands of feet of film wait to be exposed. Some cameras are only inches away, housed in steel boxes with Pyrex lenses. 200 eyes, all focused on one object. launch pad cameras have shut down, and the tracking cameras take over, providing a visual record of the flight, automatically following the rocket as it flings its human cargo into orbit. On the ground, they study the pictures, examine every minute detail. The film yields up vital information on the performance of virtually everything associated with the launch. During the time of launch, a central timing facility was feeding impulses to each camera. The film was marked, so now they can pinpoint the precise time of every picture to within 1,000th of a second. Even before the launch, pictures of static test firings tell them how the rocket's engines behaved under controlled conditions. And where there is failure, the pictures tell why and point the way towards solutions. Failure or success. Failure and success. Photography, linked to new techniques and developed to new levels of sophistication, provides a means of measuring performance of the intricate machines of the space age. But not only on the ground, the machines take their cameras with them inside and take their own pulse and temperature readings. Separation of the stages. Did it occur as planned? The dynamics of fuel in a weightless state. Did it work as theory said it would? Again, the pictures provide answers, but not easily. The stages of the rocket drop away and plunge back to Earth, and the cameras and their pictures are fished from the oceans of the world. The answers they provide are worth the search. And the men of space take their cameras with them, measuring performance, but also providing a visual record of the strange reality they experience. And in the process, they provide us with a record of the sublime beauty of space. In giving us a record of the beauty of space, they also present us with a portrait of ourselves, startling and beautiful. Some dim perceptions, some hint of questions not answered, some suggestions of problems and solutions begin to rise to the surface. But not so fast as to obliterate our surprise at the beauty of this tiny blue planet. Pictures of Earth also record the problems. They give us data we need for action. Agnes, Beulah, Cindy, Debbie. Those devastating women of the hurricane season have been tracked, pinpointed, evaluated through the use of satellite pictures. Before the first weather satellite, Tyros, our knowledge of the weather was limited largely to what was happening in our backyard. But the view has expanded even from those early days. We can now watch weather patterns across the face of the globe. We've gained new understandings of the dynamics of weather and have developed ways of translating those understandings into vital applications. The weather pictures are studied, scrutinized, evaluated, checked one against the other, and they're checked against the data from other sources, ground stations, local observations. The process is a fusion, a blending of a number of complex elements. The perceptions of man, his background and experience, the machine, electronics and optics. They all play an important role in this process, and photography is central to the drama. Weather pictures, for example, no longer are received at exotic receiving stations. Automatic picture transmission can bring satellite pictures of weather to any user through relatively simple and inexpensive equipment. In this fusion of elements, the raw data is coupled with man's understanding and then given over to the technology of the computer age. The result? Forecasts of long range covering wide areas, not only for our own backyard, but for those around the world. We no longer wait for the rain to fall. If the rain is more than incidental and is coupled with high winds and high tides, then such knowledge is critical. A hurricane is seen from a satellite. Hurricane Camille in the Gulf of Mexico, bearing down on the Gulf Coast. But it's seen in a way that would boggle the imagination of early weather watchers. It's seen as different colors, and not just for the sake of color. Each color on the scale, each gradation of color, represents important information. Temperature readings which, in turn, give clues to the intensity of the storm, its path, its probable behavior. The techniques developed during the early years are refined. The technology is pushed. The minds of men are stretched. And the lives of people are saved. In the course of the space program, the men, their machines, and their cameras left the Earth and its orbit and extended the search beyond. 1964, the Ranger spacecraft sped toward the moon and sent us back our first close pictures. We watched as the spacecraft headed toward impact, surprised, intrigued, awed. And then, Lunar Orbiter. It circled the moon, sending back pictures of startling clarity, and we began to fill in the details of the geography of the moon. Fouth, the keyhole crater, and just beyond, Copernicus. For the first time, we grasped part of the meaning. The moon, too, has its canyons and mountains and valleys. The scientists began a systematic job of mapping the surface. One day, men would go there. But before that, their sense of sight, remotely controlled and contained in a spacecraft, had to go first. And the revelations were there. Impact craters and rills. Examples of ancient lava flows. Chaotic terrain. We saw the terraced walls of craters and craters within craters. And for the first time, so clearly, we saw the so-called dark side of the moon, the other side. In the workroom and laboratory, man paced off the surface of the moon. And then, the real thing. Again, pictures provide a record of accomplishment and achievement, and important scientific information. The footprint of man, preceded by that of an earlier visitor, Surveyor. It had landed and provided much needed information on the surface of the moon, scraping and digging and photographing the results. And through the use of a special device, converting black and white images into color, details, clues, things that had to be known before the first astronaut touched down. And even after the manned landings, Surveyor continued to provide information. By checking on its condition, the man on the moon learned something about the moon itself. The astronaut did something else, too. Something that all visitors to a strange land do. He posed in front of an imposing landmark, one he brought along for the occasion. The names of the places visited still ring in our ears: Sea of Tranquility and Fra Mauro, the Ocean of Storms and Litro. He used these pictures to define the limits of himself and his machine, and measured the performance of both against those defined limits. Increased mobility gave him more freedom. Freedom to move farther and farther away from the mother ship. He could now move across the nearest hill and down into the nearest valley, seeing things he would not otherwise see. New tools and new technologies were harnessed for this quest for knowledge. The spaceman, the astronaut, sent back an instantaneous record of his accomplishments, 250,000 miles in a fraction of a minute. Turnabout, then, is fair play. We sent signals back to him, telling him what we wanted to see, even controlling the actions of his television cameras. And throughout the world, people watched. We soon learned that television was no gimmick. Apollo 13 brought the message home. Television gave ground controllers instant sight and insight, and permitted them to make lightning-fast decisions to save the lives of 3 men in a damaged spacecraft 250,000 miles from home. Back in the laboratories of Earth, we learned to learn new things from the samples brought back from the moon. Specialized optical and photographic techniques are used to query the sample, to go backwards in time. How far back? 4 billion years? 4.5 billion? Photography helps to scrape away the layers of centuries and magnify the detail that would escape the naked vision of man. A glass bead from the surface of the moon. It's magnified. Then again, and then again, as if we were peering into other worlds, other universes, asking more questions. We also reach out to other worlds, other planets, to Mars. In a room in California, a room jammed with electronic and optical equipment, they waited for the first close-up look at Mars. A look to be provided through the cameras aboard a spacecraft that would glide by, clicking its shutters every 48 seconds. And it came only 1 year after Ranger sent back its pictures of the moon. Mariner had done its job well, and others were to follow, will follow, adding to the storehouse of information. The details fill in, and the scientists find striking similarities between Mars and the moon, and some striking differences. Craters, like the moon. Polar ice caps, like the Earth. And a moon of its own, one of 2 photographed by Mariner. And what does it all mean? Is there water on Mars? A form of life? Scientists continue to debate the issues, but slowly the mystery is being stripped away. The computer lends valuable assistance, wringing from the pictures clues and secrets. Interference patterns are translated into enhanced and clarified pictures of the Martian surface. Then if it works for Mars, why not for other planets? Our own, Earth. The irony of ecology. The farther we moved away, the closer we came to understanding the importance of our own environment, of simple, peaceful lands, and how to save them. And disasters, and how to fight them, control them. The forest fire is seen from orbit, pinpointed for those on the ground. Accumulated technology is now harnessed to preserve our own planet. The Earth Resources Technology Satellite, ERTS. It's a big step in that direction. It looks at the Earth through completely new eyes, feeding us vital information on ourselves It also returns telemetry data from ground-based stations, serving as a sort of orbiting collector of information. 500 miles above the Earth, it tells us the things we need to know. And ERTS, coupled with Skylab and Space Shuttle, will provide unprecedented opportunities for new views as we monitor the resources of the Earth. We also receive information on our growing urban centers, information on sources of pollution, population density, terrain conditions for future expansion or for future conservation. Leave the generalities and look at the specifics. An orange grove is infected with blight, and an infrared photograph tells the grower the extent of blight. From this, he will deduce a solution. The techniques are varied. A basic color photograph is subjected to different filters, layers of color, and each layer provides new information. The same techniques, with variations, can be used to detect a wide variety of problems which threaten the resources and people of the Earth. And the results are being made available to people the world over for the solution of problems. For example, multispectral photography. It reads the non-visible parts of the spectrum: X-ray, ultraviolet, infrared, thousands of images providing information and understanding that is beyond value. The promised 20,000 images of this film have almost all passed before our eyes, but others are to come. Images of the future. This new view of space. It also provides us with a new view, a new understanding of ourselves and our role in that future.